Hi, in this video I'm going to do the detection of two small molecules, but what I'm really describing is the detection, identification and quantification of APIs or active pharmaceutical ingredients that you would find really in drug formulations. Now the particular APIs that I'm interested in are actually fall into the category of small molecules. So what I'll be able to demonstrate in a minute is a system that is quite capable of detecting APIs, detecting them, identifying them, and quantifying them. It's very simple to use, and I will show that shortly. Now, where we imagine this to be actually used is in the probably in the manufacturing process and the quality system that kind of runs alongside that manufacturing, possibly in the synthesis, or possibly in the formulation, possibly in the purification. But first of all, let me show you what we have. Now, the first thing to say is about these small molecules is these would all be essentially detectable because they have some characteristics, which is they often have an aromatic ring, and they often have a heteroatom, and that heteroatom is often, not always, but often covalently bonded directly to that aromatic ring. And if we can kind of meet these criteria, then that means that the molecules are intrinsically electrochemically active, and we can probably detect them on the SIA platform that I have in front of me. Now, to kind of illustrate this, I'll do two live demos. One of them will be caffeine, and the other one will be capsaicin. And you can see here that they have they have aromatic rings in them. They also have heteroatoms, and those heteroatoms happen to be covalently attached to the directly to the aromatic rings. So we kind of tick those two criteria, and this means that these APIs or these small molecules are electrochemically active, and they're not hugely dissimilar to that list of APIs that I actually gave on the first slide. Now, I will do a live demonstration in a minute and do it twice so you can see both those molecules. But just to say that I have the SIA platform in front of me. I have these electrochemical sensors here. These are nicely functionalized. What you'll see is this is a very rapid way of doing detection. You'll see that we have the capability of taking just a very small sample. I only need about 50 microliters. You'll see that we can actually go between different small molecules just by using a QR code. It's just to say that the instruments actually run off the phone, and the phone knows what to do because of QR codes, but you'll see me do that shortly. The method file that will be particular to a certain drug is sent to the device. The device sends back the raw data. The raw data is actually turned into a concentration on the phone, and so somebody and I say phone, I should say smart device, that can be written down and put into a quality document or quality record. But at the same time, it's also saved, and we have the raw signal, the actual concentration, the time and date, who did it, and if we need to as well, we can also open up and actually do a sort of GPS on them as well. So there's a lot of both transparency in terms of number, raw signal, who did it, and also traceability because of that time date aspect to it as well. So the first one I'm going to do is actually caffeine. So what I'll do is I'll go to an external camera here. So I've got the sensor, really easy to plug these sensors in. So no slots, just close it up like that. I will take a sample. In fact, I've got a sample in the pipette now, just 50 microliters onto that. I hit continue, I hit start, and it's actually running it now. So you kind of get, the user will get that kind of experience that, oh, at least something's running, and they're not sitting there sort of twiddling their, necessarily, sure they're not twiddling their thumbs, but they won't be sitting there wondering if something's happening. They can kind of get this visual feedback that the system is actually running, and they get a progress bar as well. And then it's uploaded the data now. So I'll just hold that to there. So what this says is, now we've got this one set up to deliver it. It says that there's 87 milligrams per gram. So what that means is we put a solid formulation in there. In this particular case, it was basically, as you can appreciate, a caffeine, a solid source of caffeine, but it gives you an idea of the concentration per gram of caffeine in that. Now, I did say that there was a good transparency to this as well. So what I want to do is just go to what I call the screen here. I'm just going to do a quick refresh because the data is actually all saved at the same time. So that will just upload. And there it is. So now what I'll do is I'll click here. and I can get a really good sense of this. So you can really see no signal, no signal, no signal, and then we get this kind of very distinctive peak. So you can appreciate then that, you know, I can assign that to the API. The software has identified the peak, it's measured the peak height, and it's actually converted it then into the concentration that was actually reported. And I can see date, time on this, so 7th of January 2025, approximately 5:15, and who actually did it, and even the batch ID, etc. So that gives you a sense of, I got the result. It was quite easy to find that result because, hey, it's on my phone, so you didn't need to necessarily, you know, understand all of the science behind it. But really, for a quality manager, or, you know, quality engineers in the process, or even the maybe the purification engineers or the synthesis engineers, formulation engineers, etc., they will be able to dig in there and find their raw signal as well. Now, what I want to do now is actually just say that it's not just a sort of essentially a one-trick pony. What I want to do then is demonstrate that, in fact, we can take the same instrument, similar sensor, put the sample on there, but a different target, driven by a different QR code, and we'll actually get a very different signal back off this, or raw signal back off this, but otherwise the workflow is very distinctive. Now, the fact that the raw signal come back very different is a good sign, because it gives you that understanding of specificity of the system as well. So let me go back to my external here. What I want to do is I just want to take that out. I will put essentially this in. I will put a clean pipette onto that, a clean pipette tip onto that, and I will show you the sample again. See, we're expecting this to kind of be coming out of maybe a formulation or a manufacturing process. This is not a transparent filtered sample. This is, you know, I don't want to say quite, yeah, it's quite bitty and definitely less than what, I wouldn't say less than ideal, because in fact it's ideal for us, but it does give you a sense of the science that, in fact, the science is robust enough. I just changed the target, by the way, just by using that QR code. So I've got that. I'm just going to give this a different name so I can find it. I'll call it CAP 101. I'm going to take out the sample. Again, it's great for the pharmaceutical industry because, in fact, it doesn't require much sample at all. And really, you can very quickly train operators, etc., to basically run this assay. And again, they'll get a real sense of that the system is working. You can see the raw signals coming in real time, and it's, you know, it's streaming onto my phone, so they're not sitting there. You know, they know it'll be working, and once they've been using this system a few times, they'll become quite familiar with it. This time we've reported it as 802 micromolar. But again, there's a great transparency to this system. So I just want to go back to the data. So let me just go to here. So this was our original signal for caffeine. Now we're looking at a very different organic molecule now. Drug-like again. And I'll click in. But you can see, look at this. It's a very distinctive signal. So, you know, in a worst case scenario, you're not going to be mixing up, let's say, drugs molecules, because each one of them will have quite a distinctive fingerprint. But there's the concentration. Here's the name of that sample. Here's time and date. Here's who did it. You know, again, you get the raw signal. Sorry, again, you get the concentration and you get the raw signal as well. So I'll just go back to here. And so that was what I was showing here. So it's just to say that we can basically develop for the particular API that needs to be identified, evaluated, and quantified. We can develop a method for each one of those. And you can see that there's a great transparency in this in terms of, and traceability in terms of this, which I showed you in those two live demonstrations. So I think I want to finish with just to say that this app is, and hardware is already released. We do actually have the app on the Google Play Store, and we have the app also available on the Apple App Store. If you do have any questions regarding this, then I'll put a link underneath here or a button next to this, and you can contact us if you do have any questions. Okay, Thanks very much.